Hello, good morning. So many people here. I am excited. Hello, waving hands, very nice. So this is a good morning, as I would like to say something about the serverless. It is a buzzword, to be fair, but I am excited about it as it is a very good tool for prototypes. So I would like to start with some story and explain why I'm interested in the cloud, in the serverless. So why I started to think about it. Let the story begin. So back in the days, I worked with the different companies, and we always start small, as we have some single service, and on the same server we have the database, we have the message broker maybe, on the different server we have FTP. It is back in the days, remember, because now we use the other technologies. But we don't need to take care on many maintenance because we have not too many servers. But then, after some time, the more traffic is coming, we have more data, so we need to decouple some of the servers because the load is too big to handle it. So, for example, we decouple the database, we decouple the message broker, and the data still grows. So we need some reports, we need some insights. So we decouple another server out of the database for the replica, just for the analyst. And for some more critical actions, we introduce some alerting. So, for example, we're sending emails. And we figure out that our system is pretty complex already. So we think about some better solution, and we would like to split some functionalities. So how to split the functionalities? Of course, to the microservices. Microservices, to not create too many servers, we put on the Docker container, for example, right? Because the Docker container can handle many services in there, and not too many maintenance is needed. But you need to know the DevOps. And to be fair, people, younger developers especially, don't really like DevOps. So something easier maybe is needed. So not handling the infrastructure we can have with some platform as a service solutions. So I worked some time ago with the PCF container. We can store the services, Spring Boot services on it, and reuse some configuration by the bindings to some services like databases, maybe some blob services, and we can have some load balancing on it, and also the Eureka is something that enable client-side load balancing based on the ribbon maybe. But we need to ask ourselves a question. Is it really a scalable solution? So what if we need to scale just single endpoint because we have Black Friday, and maybe this endpoint is utilized very heavily, but on the other days, it is not utilized at all. So are we ready to scale in and out based on the traffic? Can we deploy the functionalities independently? Well, there are some solutions, of course, but I don't really believe that we have it out of the box. So what if we could consider this kind of the application? We have no server at all to maintain. We have all of the functionalities in the Lambdas. We have some blob storage instead of this SFTP, which you remember. It wasn't very convenient to use. So S3 is cool for this solution. We have some serverless database. We have the SNS and SQS, for example, for the querying. We have some alerting or some CloudFront solution to have more efficient networking. And remember, your customers not really care about what is on your backend. They care about something more important for them. So what is it? In my opinion, it is API, because it is the way you contact with them. It is the way how you can expose some data. So there is another buzzword, API-first approach. I will not explain this in this conversation because it is another topic, but there is one important note. We need to focus only on the endpoints that are really needed for the customer. Why to spend the time for implementing something which is not used by anybody? So define the endpoint, use some tool for it. So there is the standard of Swagger or OpenAPI. Design some data. For example, in my demo, I use the nodes. So the nodes has some name, has some text, has some users, but we have some identifiers for the backend also. We have some create date, which is calculated in the backend. Decide what are the endpoints and define what is the response to that. So for example, as nodes response is the array of the nodes. Of course, we can post the nodes in the other endpoint. So we have our API. Let's start to build something. So we have some technologies in different clouds. In AWS, we have the API gateway. In Azure, we have the API management. In GCP, there is also the API gateway. They have the APG also, but I focus only on those three in this presentation. Let's find some computation technologies. So, for example, AWS Lambda, Azure Functions, Cloud Functions on the GCP. Choose the database. So, in Amazon, we have DynamoDB, for example. We have also Aurora, but I am focused on the DynamoDB today. On Azure, we have Cosmos DB, but we have also Azure SQL Database Serverless. And in the GCP, I am focused on the cloud data store. It is really easy to use. That's why I choose it. So, put together. So we have the API gateway. We connect some lambdas to it, connect DynamoDB to the lambdas. On the API management, we bind the Azure Functions app and bind the Cosmos DB to Azure Functions. On GCP, we create the functions, bind them to the API, and connect the data store to our functions to the data store. On our API, we need to have some security, of course. So choose authentication and authorization schema. So for my presentation, I choose JWT tokens. It is very popular, and we can use it on every of the cloud. But there are also other options, like subscription keys or API keys. We can use some managed identities or resource-based policies or service accounts. We can use client-side SSL certificates. Also, Amazon has some service called user pools, so you can use the federated identity, and so on and so on. You can even create your Lambda authorizers for your solution, or use the basic authentication on the Azure management. So set up the database. And here, we need to set up DynamoDB. It is fairly easy and quick. Let's see what happens in the console. So we need to create the table, create some partition key. We can do the sort key also. And it is all we can do, all we need to do, actually. So we need to set up some security for our database. So we need to create some policies. We can create separate role. But for my solution, it is enough to create some inline policy for my functions, just to enable the APIs I need. So for example, put item. and I add the privilege to put item on some region to some table name. And it is all. Not much to do, isn't it? So for Azure Cosmos DB, we can many options. Recommended way is to use core SQL API. It is just the API, so under the hood it is document database. Sorry. We have many other APIs also to choose if you are expert in other technologies. So we create the database, assign it to service group, define the name. I will choose, of course, serverless option. We need to wait a couple of minutes to have it created. We need to set up some env on the Azure because the Azure functions are created on the function app. So to do it, also we need to create some service. So very similar approach as the Cosmos DB. We need to create some service in the service group. I choose Node.js for this as the runtime. Couple of minutes to wait to have it, but that's why I recorded all of this, because I don't want to wait. It is not very interesting to wait. So let's do some fun part, so coding. And coding on AWS Lambda is very easy. So I choose the Node.js because notation is very, very simple. We need to import some SDK. Create connection to the database. Remove some sample code, of course. Consume the body. So in AWS we have different body schema because if we choose Amazon API Gateway HTTP option, we need to read the body from the string. But in the REST API option, we have some mapping. So we don't need to do it. And when we have the body, we need to create some entity, some database object. So here I created. I think we could it wasn't very interesting, so that's why I decided to make it faster. So we set also some ID on our backend, and we set the created date. In the ISO format. So we have DB object, so we need to store it. So we use the API put item. Wait for it. I forgot in this video to specify the table name. It is very important. And then return the body. And it is done. That's simple. Deploy it. So another Lambda to be created. I will not show the video now because it is very, very similar to do it. So we just have different function. We use the scan API to read the nodes and just map the nodes to the response body. On the function apps, we need to make sure that database is created, install some dependencies. So I needed the UUID to use the UUID before. Create the function. So when I create the function, there is a very cool option as we can choose from many of resources. I choose the HTTP as we are creating the API. We need also some binding. So to the database, we create some integration. So we choose the Cosmos DB, of course, specify the table name and container. I didn't create the table before, so I chose to create it for me. Create the connection, and it is done. So that's why we will focus just on the code, on the connections in the code. I make it faster, maybe. Okay, sorry. It. Sorry. Okay, let's watch it again. Sorry. I think that work like I expected. Sorry. Okay. So again, we can see how we create the function. So there is some difference in Azure and GCP that we consume the HTTP body instead of the events. On AWS, we consume the events, so it is a little bit different. Another integration here. So it is again what I did before. So table, collection, create the table. I didn't say that we also have the partition keys on this solution. It is very similar to what we have in the DynamoDB. So this time, let's wait. I think that I couldn't make it faster. So in the implementation, we need to import some libraries, of course. So here we have the post nodes. So we need the UUID. Of course, remove this sample code. Consume the body, very similar like we did in the AWS. We can also return some 400 in case of nobody. And if we have body, We set the ID. Similar concept to before, as we create exactly the same app on the different clouds, just to compare how easy it is on each of them. So we set also the date of creation. Get the binding and set the body to the binding. Create the response. So for sure it will be not pet request if we have body. It will be 200. I did some mistake here in the implementation, so in the video I just copy pasted some solution from different website, which I used to learn it, as I'm not Node.js developer, so I needed to figure out what happens. And we needed this just to make sure that it will be created in the database. So I needed to correct this mistake. And now it should work. What happened with the screen? Okay. Let's go next. So on the functions in the GCP, we create the function. We choose the region, choose the trigger which is HTTP again. We can choose different trigger for different solutions. For example, for the quiz. We install some dependencies. So the dependencies I need is the Google Cloud Data Store. Import the dependency, of course. Create connection. We need to specify the project and the namespace. In data stores, data is stored in the namespaces and has some kinds also. So remove the template code. We implement now the get method. So we need to run some query for some entity. So the entity kind type is node. We need to consume the results of the query, so run the query. And pass through the results to the response. And other function to be created. In this case, it will be put method. Install another library, UID, before, as we did in the previous examples. Of course, the function will look differently. So we need to consume the body. If the body is null, we can respond with bat request. And otherwise, we set some ID to body. Also created that. Exactly the same setup as we did in the previous examples. We need to wait for data to be saved. So we need to pass the entity with the key. Key consists of the kind, and the body, ID. It is done. And we have the functions now. So we need to bind the functions to the endpoints. So starting from the AWS, we need to create some integration, then use the integration and attach it to each endpoint. The type of the integration is Lambda. We have also other types of the integrations to play with. And it is done. So moving on to the Azure. In the Azure, we cannot bind the service immediately. Unfortunately, we need to set up some input policy. So it will be able to see it on the screen in a second. So add the policy, other type of policy. Add the policy to use the backend ID. In the backend, Azure app functions app has the triggers which use the name of the function. So we cannot just bind the function app. We need to also rewrite the URI. So there is another policy to rewrite the URI. And from my specification, I had the nodes, so I need to rewrite it to get nodes and post nodes, respectively. So in case of GCP functions, everything needs to be defined in your Swagger file. So you need to put your trigger URL to the Google backend address. And now we need to set up the security, as I explained it before. I decided to use the JWT tokens of Auth0 starting from AWS API Gateway. Here is the example that endpoint is working even without the authentication, so we would like to set some security. We create the authorizer with some name, set up the issuer URL, and specify the audience. When we deploy it, we can test it. So without the token is unauthorized, and with the token it works. Let's do the same setup on Azure API management. So it works without the token. Here we have the integration with Open API endpoint. So we create the policy, validate JWT policy. Specify the OpenID URL, issuer, information about the token, and the header for the token. Authorization message in case of unauthorized requests. Here is it, how we set the token name in the header. Specify the audiences. And it's done. So we have the unauthorized response in case of no token, and with token we have successful response. In GCP, again, we need to set up everything in our Swagger file. So we create the security definitions. Here I create the security definition out0 JWT with authorization URL, type flow, type of course out2, issuer URL, key set URL, and audiences. And here we can test, so unauthorized without the token and with the token authorized. So both endpoints work correctly. So how it can scale? So of course, if it is enough to be on the same region, we can create the APIs on the multi-regions. We can create, for example, in the API gateway in AWS, there is the edge optimized option. We can use some content delivery networks like CloudFront, for example, for better networking and cache. And what we need to know when we change our minds, so we've seen 3 clouds, and my point was to compare those clouds, what we can have in the functions. So I created some comparison. So not all of the languages are available everywhere. So for example, Go is not possible to be used in Azure. Not every of the version of Python is possible to be used in AWS and Azure, while there are some differences of the versions in AWS. I did some mistake in the AWS. Also, there is possible to use the Java 11. There is their custom implementation of JDK, which is Corretto. So it is also possible to use Java 11, but it is not possible to use Java 17, for example, on Azure and AWS, while we cannot use Java 8 on GCP. In case of the .NET, it is not possible to use the .NET 6 on GCP. PowerShell is not a very popular option anyway, so it is not a problem that we can use it only on the Azure. Node.js is very popular options for this kind of the solutions, the same as Python. But PHP, for example, we have some option to use it on the GCP. We can, on GCP, also use the Ruby, and we can create some custom runtimes in Azure and AWS. There are also some differences in quotas and limits in all of the clouds. So in AWS, the minimum RAM we can use is 128, and the same for Google Cloud Functions. But there is a difference of the maximum RAM we can utilize. So in AWS, up to almost 10 gigs, and on GCP, it depends on function option you choose. You have first gen and second gen. So on the second gen, you can use up to 6 gigs. And there is also some difference of customization of the RAM, because on the Cloud Functions first gen, we can use 128, 156, 512, or 1, 2, or 4, it is mistake, RAM. But on AWS and second gen, we can do the increments of 1 megabyte. In Azure Functions app, the setup is completely different. We have the function app, which can use up to 1.5 gigabytes of RAM. What about the timeouts? So if you create some functions for your APIs, you need to take care of the timeouts because Lambda technologies are limited. So we can have the timeout of only timeout of 15 minutes on the Lambda. On Azure, default is 5 minutes, but 10 minutes can be set up. In Google Cloud Functions, default is 1 minute, but it can be customized to 9 minutes in first gen, but up to 60 minutes in the second gen. And concurrency is also different. So in Azure Functions app, we can limitation of active outbound connections up to 600 active and 1,200 in total. 1,000 for concurrent connections for AWS, and 3,000 for GCP for both options. So for me, it is the winner in this competition. About the deployment side, there is also some difference. So I consider as the best not have any limits. So Google Cloud Functions second gen don't have any limits public. So I assume that it is unlimited. On AWS Lambda, we have limitation of 50 megabytes, but unzipped it can be up to 250 megabytes. In the editor, we can use just 3 megabytes. In first gen, of Google Cloud Functions, we can have 100 megabytes of compressed sources and up to 500 megabytes uncompressed. In Azure, we have the limitation of 5 terabytes for all apps, so it is a little different quota. And in Azure, we have the biggest payload size available for functions. It is 100 megabytes. We have very small payload size in AWS Lambda, which is just the up to 6 megabytes. And depending on the version of the GCP, we have 10 or 32 megabytes. And additional storage is available only in the AWS Lambda. It is from 512 megabytes up to 10 gigs. The limitations, so GCP supports only Swagger 2.0, which is the old standard. HTTP API gateway works just with 3.0, and there is very strange thing as we can use very convenient JWT authorizer like you see before for custom JWT provider only in the HTTP option in API gateway on the AWS, but in the REST API gateway on the AWS we can use the JWT provider for the Cognito user pool, so for the rated identity, or some custom Lambda authorizer if you need to have some other JWT token. So guess how much time it took me to create all of those 3 apps? What do you think? It was about 10 minutes per each, so it is really fast. So are you convinced to do prototypes on the cloud? Okay, I don't see you, so let's see if you have any questions. Thank you very much for listening. Okay. Can you define all of these components as you code and the cloud and be a cloud agnostics? What do you think but defined all of these components? We can come back to it. We can speak afterwards if you want. Of course, some of the clouds, maybe it is your question. Some of the functions can be implemented on your own laptop, and there are some options for it. So if it is, that's okay. But if you have other question, I think that we can connect afterwards. Which cloud provider will be cheaper in this example? I think all of those are very similar, so I don't consider any of those as being cheaper. I just focused on the lambdas and functions, so all of those solutions have very similar pricing. And it is little cents per million invocations, so it is really cheap also. And so there are some free invocations per month, and you can use also the free tier if you have some count created, so there is some option also for it. Is it possible and reasonable to combine cloud services from the different providers? I think it is. And I heard about some of the solutions, and I know that GCP tried to do it in some of the cases, announce something like hybrid cloud. So yeah, I think it is possible. I never did it, but it is very interesting topic. Which cloud provider will be cheaper? Again, I think none. Is it possible and reasonable? Okay. Define as a code not to use these wizards. Okay. We can do it, but for the presentation, I thought that it will be better, but it is up to you. Of course, we can do it, so it is possible. So I treat it as some feedback for the presentation. Thank you. Can you compare cost of the Lambda versus instance? When it's better to use instance instead of Lambda? I think it is very hard because it really depends on how much you use the Lambda. But of course, if you need to, for example, provision some Platinum versions of the instances, it will be always very, very expensive to have the instance, and you underutilize it. So I wouldn't compare it. It is completely different approach. And for my workloads, I think that Lambda is cheaper, very cheaper, as it is not really easy to predict how much you use before you start using it. So instance, I think, if we have very consistent load and we can predict it, maybe cheaper, but you need to do the measurements. It is not really easy to compare it. So we need to know the case for it. We can discuss afterwards. How to put these endpoints on the public internet? It is on the public internet. So I'm sorry if it wasn't clear, but it is in the internet when you deploy it. So no steps to be done. So that's why I think it is cool to use this approach for your prototypes. As, for example, you're working with some UI guys. Maybe they are on the different part of the world. And in the few little steps after the meeting, you can create the endpoints in minutes and provision the endpoints for them. So that's I think that it is a cool option. So any other questions? Okay, thank you.